Whenever I'm asked, how long would it take to do this study? Do we have the data? How much analysis is involved? How much will it cost? I always want to provide some basics in how these decisions are made. When researchers say one thing causes another, or even one thing is partially related to another, they do so only after analyzing data from a sufficiently large sample. And the definition of sufficiently large depends on what we know about the relationship between the factors being studied, as well as the comprehensiveness and accuracy of the data available to test that relationship. To establish a defensible statistical relationship between two or more variables related to individuals and their behavior, we need as much data as possible, and for many individuals as possible, both those expected to have positive behavioral outcomes and those who may have negative or unwanted outcomes, or something in between. Traditionally, researchers talk about one thing causes another in terms of X causes Y. The Y is the dependent variable. X is independent variables, the thing that causes Y. And there could be multiple X variables. But think about how you would portray this if you just had one dependent variable and one independent variable, or one thing on the y-axis and one thing on the x-axis. We would have our ability to look at each individual case within our study based upon their position on these two axes. Let's say we had four things. Those could be four people, they could be four departments, they could be four places. And you can see the relationship between those who score low on the x-axis, or the cause, and those who score low or high on the y-axis. So if you saw this, you only have four cases, but you think, well, it seems to be that scoring high on the x-axis produces a high score on the y-axis, and you might feel confident saying that, but you only have four cases. To make it more practical, let's think of the y, or the dependent variable, as someone's grade in an algebra class in junior high or high school, and the x would be their class attendance. So all we have are data about when students went to class, and then we collected their grades. If you saw these four students, you'd see the one who attended class the most had the highest score overall in their algebra class, and you'd feel comfortable saying that was a relationship. But what if we start collecting more data? We have more students. Suddenly, it starts to deteriorate a little bit. We now see students at various levels of attendance with different scores. For example, this student barely came to class, as one of the lowest attenders, and yet had the highest overall score in the class. Maybe that was a future Albert Einstein, someone that didn't really need to study or take class because they just naturally were going to get a good grade. And then you have others, like this student, who attended class a lot, one of the most frequent attendance records, and yet had one of the lowest scores overall. Maybe that student was in class all the time, but spent all their time talking to their friends and flirting and writing notes to each other. But as we collect more data, the relationships start to get more complicated. Now we start to feel comfortable. We see the scores starting to accumulate along that diagonal line from low to high, which means in general, people who had lower scores in attendance tended to have lower grades, and people who had higher attendance tend to have higher grades. And a researcher would draw a line there using statistics. That would be the regression line, basically a measure of the overall relationship between these two things. The distance between the cases that are far away from the line create the overall variance in the model. And what a researcher wants is to have low variance. But we just have two factors. So we're only looking at attendance and their grades. We all know that there's more than just attendance that produces a student's grade. There's the extent to which they concentrate on the class, they do their homework. So what if we had multiple variables? What if we build an index rather than just measuring class attendance? The index might include a measure of how often they paid attention to the teacher, how often they did their homework, whether they took consistent notes, whether they read the book. All these things could be combined into something called an index. And if we had an index, we might find that we'd lose some cases because we couldn't get the data for everybody, but it would be a stronger predictor of their performance, of their grade. So basically, the number of individual records required for a study depends on what we know about the variables involved, the populations involved, and the temporal proximity of the phenomenon we're trying to explain. In other words, if we're trying to predict something that would occur months or years later, you need a lot more data. Also, when outcomes vary greatly among individuals and researchers don't have enough data or the right data to identify the true sources of variation with sufficient precision, the analysis is hindered by measurement error and unexplained variance. To establish a relationship between, say, pre-employment screening and subsequent job performance, a study would need a large, anonymized employee data set stripped of personal information that could enable researchers to identify individuals. In other words, you could have age, sex, and race in the data, but you might want to collapse age into categories so that you can't identify individuals. You need data about a common set of background variables for all individuals in the sample, including information before the pre-employment screening even happens. So their education, prior job experience, and so forth. 3, you'd want a common set of on-the-job performance measures, whether or not an individual is later sanctioned for poor performance. So you'd want routine performance records anytime someone's written up for any kind of problem. You'd want to have all that because those would go into your overall index trying to produce a prediction of their on-the-job performance. Number 4, data for people in 3 categories. Those who end up performing very poorly, even being terminated, those who perform very well, have a spotless record, and those whose performance is in between those 2 categories. You cannot do a study with just data about poor performers or people that were terminated. You need all 3. And finally, you need data for a long enough time period that you can capture enough information about the non-performance problems. You wouldn't want to do a study of employee performance post-employment screening and only have records for 6 months, because a lot of the problems a problematic employee may encounter are not going to appear in the first 6 months. It may take a while. I would recommend you set the clock based upon your expectation of how long it takes for problems to appear. So if half of all employees who were eventually terminated become known within 2 years, I'd want to at least have data for that 2-year period. I hope this has been helpful and not too painful to sit through, but this is how researchers think about data and why we ask the questions we ask when we're trying to design an analysis.